All right, everybody, thank you for joining us today for the Electric Fleet Advantage webinar. My name is Megan Broom. I'm the marketing coordinator here at Electric Avenue. I'm super happy to introduce our speaker today, who is Mark MacDonald, the founder and president of Electric Avenue. In 2001, a newly graduated Mark MacDonald thought he was set for life when he landed his dream job at Nortel Networks, the largest tech company in Canada at the time. 1 year later, after failing to respond to disruptions in the industry, the company was on the path to bankruptcy and Mark was jobless. Witnessing a tech giant like Nortel fall due to lack of foresight and action was all Mark needed to take his future into his own hands. In 2003, he started his first business designing and installing home automation systems, which he sold 3 years later. For the next decade, Mark honed his technical problem-solving skills to help engineers, developers, and electricians design the power spaces all over Atlantic Canada, which led him to merge two companies in 2016, forming Catalyst Sales and Marketing. In 2018, he started a renewable energy company, and in 2021, founded Electric Avenue, an electric vehicle charging company that sells both hardware and software. Today, he sits on the board as the Strategic Alliance Chair for the Atlantic Canadian chapter of the Entrepreneurs Organization. He also serves as a sustainable energy advisor on the Community Council for FIDA Living, a development company raising the standard of affordable rentals in North America. While his dream job may not have panned out the way he thought, it did set him up in ways he never could have imagined. Mark credits Nortel for teaching him an invaluable lesson about business and life, to never rest on your laurels and that the status quo is never the option. Before we get started, if anybody has any questions throughout the webinar, feel free to put them into the chat and we will address them all at the end of the presentation. Thank you, and I hope you enjoy.
Thank you, Megan, and thank you, Jill, on our marketing team for putting this together. I think it's an important topic, and I know we only have so much time to cover it. Important topic for a few reasons. One of the big reasons is just the opportunities that are out there, not only for our reps, but for our distributors and ultimately fleet customers who have joined this webinar today. It is one of the biggest conversion spaces when we look at electrification, specifically in the transportation space. So topics that we're going to cover with you today are, one, why go electric? More broad and more holistically, why are companies and why do you potentially as a fleet operator want to go electric? The challenges around electrification and some tips to overcome those challenges. And I'm sure we've all heard of plenty through the news cycles and media that's out there. Also, timing the transition. I think this is critically important, especially with some funding programs now coming to an end, with costs becoming closer to parity with the vehicles themselves. Timing the transition from a ROI or CapEx perspective can be crucially important, specifically right now at this point in time. We'll look at some case studies. One of our favorite was SaskPower, as well as some large publicly traded companies who have made this decision, not only from an ESG perspective, but also from a ROI perspective, and then also helpful tools and resources. So we just want to share things that we use in our day-to-day, also that any customers, distributors, or reps or contractors who are on the call can also use to help calculate or make the shift to electric vehicles a whole lot easier for those fleets. So why go electric? Anyone who's been on my presentations has probably heard this story before, but I want to start with it. It's not our first generational transportation crisis we've had. I know we're talking about the future of vehicles, but I want to start by looking at the past. This was an environmental crisis that the London Times, this is in 1894, the London Times dubbed this the Great Manure Crisis. And the Times predicted in 50 years, every street in London would be buried under 9 feet of manure, because you have to remember the mass transit system for all of the major city centers, developed city centers in the world, was horse-drawn carriage, or horse and buggy. And they were trying to figure out a way to deal with this transportation crisis. And despite huge and fierce debates among, urban planners, various studies that looked into solving the problem, no solution for the Great Manure Crisis was ever found. It was a disruptive technology that solved the problem for them. It was Henry Ford, Carl Benz, Daimler, and others who introduced motorized vehicles and the internal combustion engine at a mass scale. So my point here is, it wasn't the first time a better technology saved an industry and an existing problem. And I will argue that the exact same thing is happening now with our current global transportation system. If you look at how far we've come in over 100 years since the original mass production of that internal combustion engine in the automobile, it takes you to today. And how far have we come? The answer is probably this. The Bugatti Chiron, for any car enthusiasts out there, or even the layman, they're probably somewhat familiar with this vehicle. It generates over 1,600 horsepower. It goes from 0 to 60 miles per hour in 2.4 seconds. And you can have this beautiful vehicle and piece of modern engineering for 4.7 million US dollars. So this is now the pinnacle of that internal combustion engine in the automobile. And the same way the combustion engine disrupted the horse industry or the equestrian industry, I want to make the point that the exact same thing has already happened to the internal combustion engine. This is the Tesla Model S Plaid. It does 0 to 60 mile an hour in 2 seconds, so 0.4 seconds faster than that Bugatti Chiron. It runs a quarter mile off the factory floor in 9.3 seconds. It doesn't matter if it's sea level or you're sitting at 10,000 feet. It will run that time regardless of all the ambient conditions. It has a top speed of 320 kilometers an hour. It drives over 600 kilometers on a single charge. You can add 200 kilometers of range to this vehicle in 5 minutes on the new superchargers that Tesla has out there. It even has a boat mode. If you get stuck in a flash flood, it will seal up and allow you to run those tires freely to hopefully get you out of a sticky situation. It also has a biodefense mode, which creates positive cabin pressure and uses hospital-grade HEPA filtration systems, which can help during difficult times. Even what we've seen, I don't know if anyone saw the announcements in LA, Tesla has moved the majority of their produced Cyber trucks to LA to help with some of the air quality issues and as backup power sources there. You get all of this for $150,000. Straight line performance exceeds that Bugatti Chiron at 4.7 million, and you get all of this in an electric vehicle for $150,000. Now, I recognize they're not right for everyone yet, but I assure you that time is coming. And if we look at where we are on the adoption curve, I just want to talk about two things quickly: the Gartner hype cycle and traditional product adoption curve. So anytime you have a new product, you have the innovators, or what are known as the trialists, and you have the early adopters. Those two market segments are statistically a very low percentage, and they don't move a technology into mass adoption. We have to get to the early majority, which is the pragmatists, and then you have to get to the late majority, which are the conservatives, and ultimately the skeptics or the laggards. They're the ones that come kicking and screaming because they don't have another option. There's no other technology available at that point for them. I want to make the point that most products never bridge what we see here, the chasm. You've got the innovators, the early adopters, and the product, you get a lot of hype around it. It just doesn't make it to mass market. And for anyone who is familiar with the Gartner Institute out of the US, what they offer is predictive indices based on the hype around new technologies and that real world adoption. So if we look at that Gartner hype cycle, what we have here is an innovation trigger. So something has triggered the event, scientific research, whatever it may be. Then you have hype. That's where you see this large blip on the curve. You have hype around the technology. So you hear the news reports, everybody gets excited about the applications, but you get this massive dip of disillusionment around the product because it never has lived up to its expectations. And then what you eventually get is either that chasm, the product never makes it, or some enlightenment around the product, and then some plateau of productivity or economies of scale. And I would argue the same is happening right now with the electric vehicle. Here's a advertisement from a newspaper in the early 1900s. This is the, I believe it's the Fritchel Electric. So in the early 1900s, electric vehicles represented 1/3 of all vehicles on the road. Of course, there was only thousands of vehicles on the road, but it was the electric the internal combustion, the steam engine, and of course the electric motor. But unfortunately, with a primitive grid at the time, the electrical grid was extremely primitive, and cheap access to oil, distribution, and dispensation, combustion engines won the day back in the early 1900s. So the technology is not new by any stretch. Where have we come since then as a percentage of vehicles on the road? So if we look at electric vehicles going back to that Fritchel full electric in the 1900s, and we move out today to 2024, where we just actually get the numbers. We hit an all-time high of almost 18 million electric vehicles sold globally this year in 2024. That's a 19% increase from previous year. It's a 450% increase from 2020. But if we look at all these data points, I just want to highlight something down here. 2012, 2011, 2012, 13, 14, you start to see this growth, this compounded annual growth for EV adoption. And something happened in 2012 that really changed this industry now forever. In 2012, I would argue this was our trough of disillusionment around EVs, because in 2012, 2011, Tesla launched their first mass-produced automobile, which was that Tesla Model S. But the market was very skeptical. In fact, the market was so skeptical, in 2012, Tesla became the most shorted company in the history of the stock exchange, which meant more people were betting on Tesla to fail than to succeed. Push that out to 2024. I know there's a lot of hype around that stock with what's gone on with the US election, but even before that, Tesla was the first automotive manufacturer ever to hold $1 trillion market cap. Their closest rivals, Toyota, still sit just over 200 billion in market cap. So if we look at that hype cycle based on real world adoption, the hype was early in the early 1900s. The disillusionment was in the early 2010s, 2011. Now we've moved to this plateau of productivity, and there is no turning back. So if there's still naysayers on this call who are unsure if this is the right choice for them, short-term or long-term, to make the conversion, I hope some of these data points will help. What are the other benefits of going electrics? One of the big ones, of course, cost savings and ROI. For most people, environment matters, I'm sure. Maybe some people debate the merits of that, but pretty much everybody can understand cost savings and return on investment. There is also that environmental impact. There's regulatory standards that are pushing that. And there's also brand reputation and competitive advantages, which we're seeing with some big public companies, as I mentioned earlier. So let's talk about cost savings. If we look at the study from Pacific Gas and Electric, who has some of the best exposure to this being in California, if you look at a fleet of 20 electric delivery vans, they saved over $2 million in fuel costs over 10 years compared to their diesel counterparts. The Ford F-150 comparison, fuel costs for an electric F-150 Lightning was nearly 45% lower than its gas-powered counterpart over 45,000 miles, and that source came from Car and Driver magazine. So massive savings just on fuel, and we'll talk about that total cost of ownership here in a bit. Maintenance, this one is often forgotten or not thought about, especially for people who are converting from an internal combustion engine and really don't have a lot of exposure to the simplicity and the beauty of an electric vehicle. So a big one is, from a cost savings perspective, no oil changes, right? All of the liquid systems in an electric vehicle are closed source lifetime. Fewer brake outside of course, the windshield washer fluid. Fewer brake replacements because you have regenerative braking. So those electric motors turn into generators during deceleration, and they actually save a significant amount of wear and tear on the brake system. And just less frequent part replacement in general. Tesla Model 3 owners, that's one of the most adopted vehicles, or it was for a long time until the Model Y came out, one of the most adopted electric vehicles ever, reported annually spending $310 on maintenance, and that's compared to almost $1,500 compared to a comparable ICE vehicle. And that source, again, was Car Edge magazine. Also, a study by Consumer Reports found EV owners save an average of 50% on maintenance and repairs over the lifetime of the vehicle compared to those ICE vehicle owners. And just broadly, why is it? I know I talked about a few of the low-hanging fruit, but if you look at a combustion engine, all of its pulley systems, all of its camshafts, everything that makes that motor and transmission and gearing work, you're talking over 1,000 moving parts on a low-end internal combustion engine vehicle. On a high-end vehicle, you could be over 2,000 moving parts. Electric vehicles on average only have about 20 to 30 moving parts. So significantly less opportunity for failure. Incentives, the nice thing now with the cost parities that we're seeing is these things matter less. Some of the incentives have gone away or going away, have been announced will go away in both Canada and the US. But there are still some incentives out there at the state level, at the provincial level. There's also tax benefits for moving to green things, green capital assets like solar, like battery, like electric. We have accelerated capital cost allowance, so you can write off that vehicle in the first year. So still plenty of opportunities to be incented to buy an electric compared to an internal combustion engine. Just some of the major federal subsidies are going to go away early this year. The environmental impact. I think, I don't want to turn this into a political debate. I know sometimes the environmental piece can be a partisan issue, but really air quality improvements are a big one. Just if you look at air pollutants, we don't even have to talk about GHG's global effect on climate, but reducing air pollutants like nitrogen dioxide and particulate matter improve public health. Carbon footprint, right? Switching one fleet vehicle to an electric can save you up to 5 metric tons of CO2 annually and support sustainability goals. So if you have environmental, social governance within your organization, this really aligns with those efforts that we see from most major brands out there. And I always like to share this shot. These are images actually of nitrogen dioxide levels in the troposphere above China before the initial COVID-19 lockdown. So on the left side of your screen, that's what the troposphere looked like for those NO2 levels. COVID brought us significant challenges, but it also provided a glimpse of the potential health benefits of an electrified transportation system, because these nitrous dioxide levels are primarily emitted by vehicles, and they're a major air pollutant that's linked to respiratory illness, cardiovascular problems, premature deaths, and reducing its levels directly improves public health. And China's push for EVs, for anyone who knows the stats around it, China is the global leader in EV manufacturing and adoption. And their ambition may seem altruistic, or they may have it fronted as altruism for global emissions reductions, but it really likely stems from their own domestic concerns. In developed countries with public healthcare systems like China, nearly 40%, in Canada and even the US, nearly 40% of tax dollars go to healthcare. Reducing pollution like nitrogen dioxide can significantly ease the burden on a country's healthcare system. Regulatory standards, the US has been in and out. They're currently in with the Paris Climate Deal, the Kyoto Accord agreements, but the US has committed 50% of all new vehicle sales in the US are to be zero emission by 2030. Canada's federal government and provincial governments and state governments have goals to be 100% zero emission by 2035, which still may seem ambitious to some. Also, reputation and competitive brand reputation and some competitive advantages. There's a great shot here of a Rivian Amazon Prime delivery vehicle. But consumers increasingly favor businesses with a clear commitment to sustainability. 78% of consumers prefer sustainable brands, and 55% are willing to pay more for eco-friendly products. Retailers like Amazon have highlighted their commitment to reducing emissions through their electric fleet, boosting their brand image as an environmentally conscious leader. Amazon alone has ordered over 100,000 of these Rivian delivery vehicles, and they've already taken possession of 20,000 vehicles as of the end of 2024. So what are the challenges? These challenges are not unique to fleet operators. They're common with any major deployment in electric vehicle infrastructure or EVSE, but electrification challenges and how do we overcome them? So a big barrier for fleets and electrification One is range anxiety, and I will put a caveat on that. Fleet transitions do not make sense for everyone yet. Range anxiety is a real thing. So the route application has to make sense for the range of the vehicle. We have grid capacity issues. We also have driver training and technician training. They're serviced differently. You drive them differently. You refuel them or top them up differently. So we need to make sure education is a key component for one of those barriers. And then the higher upfront cost to transition. Sometimes that CapEx in that fiscal year can be a detriment to the accounting or financial team. So it's difficult to make that initial purchase without understanding the total cost of ownership. So range anxiety, we like to call this now range optimization. There's incredible route planning software to identify the best routes for EVs. They're incorporated into most of the vehicles now. You also want to select vehicles that are tailored to those specific operational needs as far as battery capacity is concerned. And like I just mentioned, if you're doing 300 to 400 miles a day on that vehicle and you have a short turnaround time, it may not make sense for your fleet today. We have to be realistic where fleet conversion and fleet transition makes sense today based on the public infrastructure that's out there. If you can't make it back to the fleet depot or a home base every single night and get that vehicle back up to full by next morning, then it may be something to consider that your fleet's not ready for the transition yet. Grid capacity, a lot of people say grid capacity, more grid readiness. In all honesty, at this point in the development and deployment and adoption of EVs, the grid is ready today. In fact, most utilities welcome fleet transition because most fleets operate during critical peaks. So they're on the roads during critical peak on the utility grid. What utilities hate is peak demand, trough demand, peak demand, trough demand. So if those vehicles are out during peak demand, they come back to the workplace or the fleet depot at 4 or 5. They can be scheduled to start charging at 8, 9, 10 when peak demand drops and we start hitting the trough. It actually offers grid stabilization, which is very attractive. The other big one is the driver and technician training programs. They are different. You have to make sure you're plugging in every night when you come back to the depot. You want to make sure the infrastructure is working. You want to make sure the battery percentage is set to the correct amount. There's a lot of differences when recharging or refueling an electric compared to what most drivers are used to. So education also critically important. So some strategies to overcome these challenges. A lot of people say higher upfront cost to transition, but I mentioned parity a few times. This is one of the reasons I've never been a huge proponent for incentives on the vehicles. I think free market economics should take place. If the vehicles are better, people will purchase them. If they have a lower total cost of ownership, businesses will do the math and purchase them. But what incentives have done in the time those incentives have been in place is they've helped manufacturing catch up because ultimately it's supply and demand economics and it's economies of scale. The more we produce, the lower the cost. China is at a whole different level. They're beyond price parity now with their electric vehicle manufacturing. They're below the cost of internal combustion engines. But if we look at the 2025 Ford F-150 Lightning versus a traditional F-150, we're only about $10,000 off or 25% off. If you factor in some of the incentives that are still available, some of the tax breaks to your business, and then ultimately that total cost of ownership and maintenance, they are just a far better purchase for your business from a financial standpoint. So timing the transition, when do you want to start converting your fleet? Some strategic considerations there. Key factors in determining the right way to go electric. We got to talk about infrastructure. Again, everybody who's looking at going electric needs to understand infrastructure development and deployment, the cost analysis. Okay, when does this make sense relative to my vehicle's depreciation and some other factors? And that upfront investment, and then fleet life cycle, when we're going to replace that existing fleet. So equipment selection, really you want to ensure adequate charging infrastructure. Do I need to include DC fast charging? Do I have quick turnaround vehicles? Do I have critical vehicles, life safety, whatever it may be? Or can I get away with level 2 charging, which is typically or is always significantly cheaper and requires less service capacity on your electrical system? Can I get away with overnight charging? Am I only doing 30 to 50 miles on average? Can I load share these level 2 chargers? So a lot of factors in the equipment selection. Energy supply capacity. So assessing the grid, typically you'll get a scope done with the utility, but grid capacity and can I plan for upgrades, not only to meet my current needs, but where I want to go with my fleet conversion. So a lot of considerations there. Site design and scalability, right? Placing charging stations strategically across your sites for operational areas to minimize downtime, optimize fleet efficiency. You get very granular in some of this decision making. Charging specifications. So how do I select my equipment? Total power is pretty common, not only the chargers, but of course the transformers and electrical equipment that's going to service them. Cable amperage, this really matters on DC fast chargers. Am I using 4D transits or F-150 Lightnings that only use 400-volt DC battery architecture? Then, hey, I'm going to have to make sure I spec 300 plus amp cables when I'm selecting my DC fast chargers once I get above 120 kilowatts. What's my system voltage? Do I only have 280, 208 on site? Am I 240? Am I 600? What step up or step down transformers are going to be required? Also connector types. Unfortunately, in North America, we love standards and standards. Everybody loves to select their own chargers or own connectors, and we've seen that with things like the iPhone's proprietary Lightning cable versus USB-C. Well, the same is true with EVs. We have the CCS connector, we have the NACS connector, we have the CHAdeMO connector. All Tesla vehicles use the NACS. All non-Tesla vehicles now in fast charging use the CCS, but there's been all these announcements where manufacturers are going to switch to the NACS connector. So how do I make sure I'm selecting the right one? What is the time frame on that conversion? What adapters do I need? And future proofing. I mentioned this before, but can my site be upgraded? Most people are starting with a small percentage of their fleet being electrified, but how do you make sure you get to 20, 50, 100% of that fleet conversion? If we look at the power requirements, this is more on the technical side, especially for any engineers who are on the call. If we look at DC-FC specifically, standard sizes, when you look at those inverters, those AC to DC inverters, we see them in 20, 30, or 40 kilowatt increments, 30 probably being the most common. That's why you see 30 kilowatt fast chargers, 60 kilowatt, 120, 180, all the way up to 360. What's the closest transformer size based on that calculated full load current? You go anywhere from 45 kVA all the way up to 500 kVA. If you're just doing level 2, and again, you're only doing 30 to 50 miles a day, you're able to do what we call load sharing, so share multiple level 2 chargers on the same circuit. You're probably only talking 10 kVA required to do 4 level 2 chargers on a 208 volt service. And this is actually the most common use case for most fleets. The majority of fleets don't need more than level 2, and like I said, unless they have a few critical vehicles that they're concerned with. Also, communications, because you want these chargers networked for a whole host of reasons. One of the most common is just troubleshooting and reliability, support, O&M maintenance plans. You want to make sure these things are networked and reporting. So connectivity requirements, you need a hardwired Ethernet, you need good Wi-Fi signal, or more commonly 4G coverage in that space, and we run the SIM cards directly in the chargers. Software integrations, a lot of people work with fleet operators like Holman, and there's others out there. Do I need integration from a reporting standpoint with my fleet operator? So you want to make sure you select chargers compatible with that. Also, what technology, we don't want to get too technical on this. We're going to keep it more general, but OCPP, Open Charge Point Protocol 1.6 is a communication standard chargers can communicate with. 2.0.1, the new ISO 15118 standard that vehicles and chargers are being built to. So depending on the use case, this is where you want to consult with the manufacturer like us or others to make sure the hardware has the most relevant technology from a software integration standpoint for your use case or application. Energy supply capacity. So the first thing we always talk about is utility service availability. Do I need a service upgrade? Hopefully the answer is no. A lot of people, if you just look at that kVA chart from before, are going to assume yes, but we have a lot of load balancing options as a manufacturer. We have CT metering systems to allocate unused headroom. in real time on a service. So there's a way we can help you get around the service upgrades. Distance from power source, how many poles, is there trenching, what type of civil work, cabling will be required, and the voltages, which we talked about before. We need three-phase, most typically or always on DCFC, single phase on the level 2, so on my 208, 480, or 600 volts. Foundation requirements, I think sometimes this gets missed in some of the cost analysis, is the civil and structural work. This can be a big chunk of deploying infrastructure. Those foundation requirements with your concrete pads, your footings, your trenching. Sometimes you have to cut concrete, pavement. A lot of the installation can be more civil than it is electrical. Then you've got the trenching and the conduit. And really importantly, always have protective bollards. Sometimes we don't see this required by construction or municipal codes, and it may get missed, but protecting that expensive infrastructure is important. So we want some safety guards there. Site layout and design, how many chargers am I putting in? We always recommend cable management systems. If you've ever been to a garage, a service station, and seen what happens with the air hose, it just lays on the ground. The same will be true of your EV equipment if you don't put cable management systems in. Signage and markings, adequate lighting, things you may not think about for a typical parking spot. Now I'm refueling or recharging my vehicle, so a little bit different from an application standpoint compared to just parking in that parking lot. And then really future scalability and expansion, modular design, plan for infrastructure to allow for additional chargers in the future. Energy storage is becoming more and more common to either augment grid availability or service size, or to help lower peak demand costs. If you're billed on demand charges, having that battery storage system there can help. And then a lot of deployments we're seeing with these large scale fleet conversions, renewable energy integration, solar, wind, something else to help lower cost and get that total cost of ownership down over time. Now let's look at that comparison. We'll go back to the economics, the total cost of ownership. We're going to compare an ICE to an electric. So if we look at the Ford F-150, gas versus electric over a 10-year ownership period. If we look at acquisition costs, this is a Lightning, but it's actually the Transit van. If we look at acquisition cost, if we look at fuel and energy costs over 10 years, maintenance cost, potential incentives, even if you take those out now at 7,500, it still doesn't move the needle much. For 20 vehicles over 10 years, you're talking $750,000 in savings, or a 40% reduction in your total cost of ownership over those 10 years. And that's why, again, get away from government and other fleet conversions. If you look at private industry, and we'll talk about it, that's why we're seeing conversion happening at such a high rate. So when do I replace? Considerations, vehicle age and condition. So mileage, what are my repair costs on it? How's the performance on that aging vehicle? Is it end of life or near end of life? Operational costs, anything that's high maintenance, we want to reduce downtime and repair expenses, which EVs help with, of course. The depreciation timeline, you really want to plan replacements before vehicles lose significant value. You still want to get optimal trade-in or resale for that existing asset. And also electrification opportunities. I alluded to this at the start, but we want to align replacements with incentive programs. I've talked about quite a few programs going away. The political climate is shifting. EVs are not going away, but a lot of people are scrambling now to take advantage of money that's been hanging out there that's very low-hanging fruit to get your TCO down even to a shorter window. And just case studies, we said we want to talk about it. I mentioned at the start, one of our favorite is SaskPower, a customer we have in Saskatchewan. So SaskPower, what's their story and why did they want to electrify their fleet? SaskPower's goal was to transition away from a gas-powered vehicle and to utilize their own generated electrical capacity. And this is one of the easiest use cases for fleet conversion because you're moving your energy from the oil and gas industry to your own grid. Why wouldn't you? It's kind of a no-brainer. Motivation, it eliminates dependency on purchasing fuel. It's a big cost saving. They can leverage that in-house generation, which I just mentioned, and reduce ultimately operational costs, but more importantly for a company like SaskPower, who's so closely tied to the province and their constituents, is the environmental impact that they're trying to have a positive effect on. So some challenges, extreme weather. Saskatchewan winters, temperatures can dip below -30, that's -22 Fahrenheit or colder in extreme cases. Infrastructure needs require a robust charging solution to support large EV batteries, especially on their medium duty vehicles and their extended range F-150s. And operational needs, they need real-time monitoring, reporting to optimize that fleet management, also access control over the infrastructures from critical vehicles and just standard staff. So the solution when they partnered with Electric Avenue, one, reliable equipment. So resilience in cold temperatures. Most of our products now is rated to -40. Fast charging capacity. They put some fast chargers in, 15 to 80% with the ones they selected in under 40 minutes. Support, warranty, extended warranty options. We go up to 5 years with full O&M plans. And then on the management side, smart management, they wanted fleet monitoring, they wanted data insights, fault analysis, over-the-air updates, tracking and managing carbon credits is a big one, of course, for any carbon emitter. All these were critical, and one reason they went with our software backend to support their smart management needs. So what have we done? Consulting and testing. They partnered with us and our sales force out there, the Titan Group, to assess the needs and pilot a solution. Started with several pilots before they committed to larger scale deployment. They installed Wadi Direct DC fast chargers at 120 kilowatts to support their F-150 Lightnings. They integrated software to ensure that management, that fleet management, and winter ready. So, winter operation ready. Ensured charging reliability on the coldest days. They tested the cables, every facet of those chargers in those extreme conditions. And the operational benefits, what are the impacts and results? So significant fuel savings by utilizing self-generated electricity, reliable performance. Like I said, we can go all the way down to -40 now, and reduced downtime. Fleet management success. They enhanced some insights and efficiencies through the software platform, faster problem resolution, minimizes disruptions to those fleet operations. And looking ahead, SaskPower is really poised to expand their electrification efforts with confidence and fleet wide. So it was a wonderful story for all parties involved. And just to close out, looking at a utility like SaskPower is one in the spectrum, but really if you want to figure out are EVs right for us, I always turn to the rigors of a publicly traded company. A company like Amazon does not make willy-nilly decisions based on potential environmental and sustainable goals. Really, it has to make good economic sense. And if you look at what Amazon has done, they've partnered with Rivian back in 2019. They announced the partnership to deploy those 100,000 electric vehicles by 2030. And by 2024, they are already at over 20,000 in operation. They also announced the partnership with Daimler this month. Amazon placed an order for 200 fully electric e-Actros, 600 trucks from Daimler for use in Germany, some medium to heavy duty trucks to support their operations. Cost savings was a big one. So if you look at it, analysts have predicted that Amazon on an annual savings could achieve up to $20 billion in savings through the adoption, not only of autonomous technologies, but the electric delivery fleet. Shareholder value, it's pretty straightforward, but beside the ESG, also lowering that operating costs. Who are some other fleets who have made conversions or announcements to convert? You got FedEx, Hertz, the United States Postal Service, AT&T. You've got Purolator, Canada Post up here in Canada. So lots still to come. Some helpful tools to close out. We have an ROI calculator on our website, which is phenomenal at goelectricab.com. I'd encourage you to use that. Also, PG&E, who we referenced earlier, has their fleet savings calculator. Website links here, and this presentation is going to go to everybody who joined after, so these links will be available. You also have Verizon Connect with their EV sustainability tool. It's another great calculation tool to help you put a proposal and TCO together. And then you've got Charge Trip with their fleet electrification and planning guide. And with that being said, we're just going to finish up with any questions. We just want to start with one. Megan's going to moderate, but I just want everyone to type in the chat. What's your biggest concern right now about transitioning to EVs? Even if we don't have time to respond to it, we just want to get some feedback. So please pop in the chat, which you should be able to type in. What is your biggest concern about transitioning to an EV? Just give a couple minutes here so people can type in the chat. Okay, so first question here, what can you offer a construction contractor looking to target EV? That's a good question. What we can help with, definitely proposals. We have a really unique proposal software or system. So if you're looking to get into EV, one, we have training modules that are available, and then two, we can help with proposals. So the ROI calculation tool I mentioned, putting a full proposal together to help you win some business, that's something we offer all of our customers, typically distributors, and also the contractors who buy from them. Next question is range for long trips to isolate rural areas without chargers. Yeah, that's what I kind of talked about earlier. Fleet electrification is tough if your range is getting outside of the battery's range, if you're factoring worst case. So what's the payload in the vehicle, and what's the range, and what's the ambient air temperature? Because all of those things affect range. So right now, plug-in hybrids, I have mixed feelings on plug-in hybrids, maybe a better option for trips outside of the range of the vehicle, or hold on to the ICE vehicles until the charging capacity is in those rural areas to support you. Next one, short runtime on vehicles and poor charging infrastructure. Yeah, Bruce, that's a good one. Like infrastructure still, the vehicles themselves, I showed you all the stats. The vehicles are phenomenal on paper, but real world, if you suffer from range anxiety and access to charging infrastructure, even here in Nova Scotia where we're based, more are coming online every month. But for a long time, we had single 50 kilowatt DC fast charging stations scattered throughout. If there was two vehicles there, you could be waiting for hours to charge your vehicle. So that use case doesn't make sense. So Bruce, we still got to wait for some more charging infrastructure. James, thank you. Appreciate it. But the range in cold climates with the price compared to ice. Yes. So again, going back, it's kind of all in the same messaging, but you got to factor that in. It's really important for cold climates, especially like in Saskatchewan, Manitoba. Lucky for Canadians, 90% of us live within 100 miles of that US border. So we only have so many cold days a year, but you definitely want to factor in worst case when you're figuring out if EVs will work for you. Yes, Jill, Ty, will you get Jill proposal contact info? They're looking for an estimate right now with a large fleet. We'd love to help you with that. And then one more here, cost of purchase. In my world, to replace a battery, I need to take out a new mortgage, and purchasing a used EV concerns me in regards to how much. Yes, yeah, good point. Andrew, nothing I can do probably to ease your concerns there, other than to say, with things coming down in price, the cost of replacement batteries have also come down. There was a study done not too long ago. On a modern EV, let's say it gets you 5+ years or just outside the warranty period of 6 years, the price of that battery replacement is going to be comparable to if you lost an engine in a modern vehicle. So it sucks for both internal combustion engines or electric vehicles, but yeah, it's a big cost. So hopefully, until the trust factor goes up, stay inside the warranty period, and maybe you'll feel more comfortable buying new. I will say anecdotally, we've got 2 Teslas in our fleet, each with close to 250,000 kilometers and well out of warranty, less than 4% battery degradation on both, and no issues yet. And with that, I know we're over time. I want to thank everybody for making the time. Some great questions. And again, Jill will get a copy of this. It's been recorded. If there's anything else you need or any other questions, just type them in the chat and we can get back to you after. Thank you so much.